Good afternoon, Ma. Many of you are missing. I don't know why. Okay, I hope others will join soon. Okay. So in this class, so in the previous class, we ended with this data integration in the process of pre-processing. We saw that whenever we do data integration, there may be problem of redundancy and inconsistency. So to improve this accuracy and to get a better model, we want to rectify this redundancy and inconsistency. And another problem we find here during the integration is we want to find if there is any redundancy, right? So for that, we we can detect this redundancy with the help of correlation analysis. So to find the correlation, we saw that for nominal data, for the categorical data, we can use chi-square method. And for the numerical attributes, we can use correlation coefficient and covariance. So by this method, we can aim to find whether there is any correlation between the variables or not. So first is to find the correlation between categorical data or the nominal data. We use chi-square method. So in the previous class, we solved the problem. I hope you remember that. So for that, the formula to for the formula for chi-square is we want to find the difference between the observed value and the expected value, the whole square divided by the expected value. So for that we saw this example. So we want to find, we have two variables and we want to say whether the qualification and the marital status have the correlation or not. Correlation means if there is any relationship between these two variables or not. So to find the relationship between these two variables, for qualification we have all these attributes, and for this marital status we have attribute. And so we said, so before we started, we have to assume a hypothesis, that is null hypothesis. And we say that in the beginning, we say the two variables we have taken is not related to each other. There is no relationship between these two variables. That is what null hypothesis. And then we have to assume a significant level. It is similar to the learning rate we assume when you do the processing. So here we have to consider the significant level as 0.05. And then this is what the observed value already given. Then this table is also called as contingency table. And from this contingency table, we have to do the expected value. To find the expected value, the formula is we have to find the total count or the number of values for this particular attribute AI, the total count, into the next variables count bj divided by the total number of tuples available in the data. So for that, here, if you take this two attributes, middle school and never married. So first I want to find the total value of middle school means it is 39. The total value of never married means 90. So we have to multiply this both divided by the total tuple. That is what the formula is, right? So we 90 into 39 divided by 300, the total value, we got the answer. Similarly, we saw this, right? For every value, we have to find it. After finding the value, we have to find the total summation. This after finding, we have to find this. We have to apply to this formula of finding the chi-square. So the chi-square formula is this observed value minus expected value, the whole square divided by the expected value. So to find each and every value, we are finding first. We are finding the difference between observed value and expected value for each and every value here. So first for middle school and never married, that is 18 and expected value is 11.7. So between these two value, we have to apply it. And then between 36 and 27, we have to apply. Then 21 and 25.2 apply. Then 6 and 16.2, we have to apply. So when we apply for every attribute, we have to find the difference, the whole square, and then we have to find this divided by the expected value. So expected value is O minus observed value minus expected value, the whole square is 39.69 divided by then 11.7. So when we apply, we will be getting this many values. So it is a big table for this chi-square is also important for an exams point of view as well. So there we won't be giving this many big data. So because it is a very time consuming, because for this particular table we have to calculate for each and every value, right? But you understand the concept. And then finally, what is the formula? We have to find the sum of all the values, right? What we found for each and every attribute value, we have to finally find the sum of all. So when we find the sum of all, we got 23.57. After this, we have to find the degree of freedom. So to find the degree of freedom, what is the formula? We have to find row minus 1 into column minus 1. After finding the significance, after finding the degree of freedom with this formula, the significant level and the degree of freedom will be seen in the chi-square distribution table, and we'll be getting the value. So for degree of freedom, we have to do this apply this formula. That is number of columns here we have is 5, right? 5 columns are there. The number of rows is 4. So 5 minus 1 into 4 minus 1 equal to, we'll get this value 12. So now we have to apply this both significant level. What is the significant level we have taken? That is what the test is based on significant level as well as the degree of freedom. So the significant level we have considered is 0.05, and the degree of freedom we got is 12. So against this two value, we have to check it in the table of the chi-square distribution. So we 12 here, the degree of freedom, and the significance level is 0.05. So we'll be getting 21.03. And then we have to compare this two value, this degree of freedom and the distribution value which we got from the table as well as the value which we calculated. So the calculated value is 23.57, but from this table we got 21.03. So the calculated value is more than the value which we got from the chi-square distribution table. So if it is greater, then we have to reject the null hypothesis. If the calculated value is greater, then we have to reject the null hypothesis, and we have to accept the alternate hypothesis. The null hypothesis we taken is there is no relationship between these two variables. So we have to accept the alternate hypothesis, which means we have to now say there is a relationship between these two variables. Let us see a simple example so that you will understand very clearly. This kind of problems you have to practice. Okay, it's important one. So here we find the relationship between qualification and the marital status, right? Now we are going to find the correlation, or we want to find if there is a relation between these two variables, which means we want to say whether male reads fictions more or female reads the fiction more, or male reads the non-fiction more or female reads the non-fiction books more. So we want to say is there is any correlation between these two variables. So that is what we want to find it. So first, according to this, what we did here, first we have to say a null hypothesis. We are saying that there is no relationship between male reading of fiction books and female male is reading fiction book more compared to female. Like that, we are taking. We are considering, they are saying no relation, we are saying, and then we have to prove it by using chi-square. So what is the first thing we have to do? We have to set the significance level. So here we are going to set the significance level as 0.001, and then we want to, next, what is the thing we did? We want to find this expected value. So here in this table, we have given it in a simple manner from the book. So here, what is out of this parenthesis is the observed value, and what is in the bracket is the expected value, the value which we calculate. So I hope you remember how to calculate the expected value, right? Okay. So how will we calculate the expected value? will you get this 90? Can someone tell me? According to the formula, how will we find this absurd value, ma? Any idea? I hope you are getting right. How will you find the expected value? So this is the formula for it, right? So how will we do it? No idea.
Ma'am,
Ah,
the screen's stuck, ma'am.
oh. 1 second. Thank you, ma. Can you see now? Is it
Yes,
coming?
ma'am. Yes, ma'am.
Yeah, thank you, ma. So now can you tell me how you got this 90? How to calculate the expected value? This is the absurd
Count
value.
up.
This, so count of male, right? So that is, what is the count of male? 300 into, this is the total count of male, this column, and the count of fiction, this one, that is 450. So 300 into 450 divided by what? 1500. The total number of tuples here is 1500. Okay, so this is how we have to find. I hope you got it. Then how will you find this 360? Now can you tell me how to find this 360? So this will give you 90. And how will you find this 360? You are understanding or not getting?
Ma'am, 450 into 1200 by 1500.
450 into, okay,
1200
very good. 450 into 1200 divided by
1500.
1500. Excellent, ma. So this will give you 360. So this is how this is the absurd value. This what is outside, and the bracket value is the expected value. So then after finding the absurd value and expected value, so we saw that we have to find the sum of all this. Sum of what? This one, absurd value minus expected value, the whole square divided by the expected value. So that is what written in a single line here. We have to find the sum of all these values, these four different values, right? So the absurd value is 250 minus the expected value is 90, the whole square divided by 90 plus, since it is a bigger value, we put it in a table. And here we just have only four values here, right? So we can directly write it. The next one, for this we can, this for this 50, we can write 50 minus this expected value minus 210 divided by, again the expected value is 210, the whole square. Then for this one, similarly, 200 minus 360, the whole square divided by 360. And for this 1000 minus this expected value 840 divided by the same value, and sum of all will give you the chi-square. So that is what the formula of the chi-square, don't forget. This is the formula, right? Observed value minus the expected value, the whole square divided by the expected value, and we have to find the sum of all. So now we have find the sum of all this. So when you find the sum of all, you will get the answer as this one, 507.93. So this is what the expected value we found it. But what we have to do next? Next we have to find the degree of freedom. How to find the degree of freedom? We have to find column minus 1 into row minus 1. The number of columns and row here is 2. So 2 minus 1, this one. 2 minus 1 into 2 minus 1. So this is according to this formula, right? This formula. Row minus 1 into column minus 1. So when we do apply that, we will be getting the degree of freedom. So based upon this degree of freedom and the significant level we have set, we have to check the distribution table. So we have to check across 1 and 0.001. So if you say in this table, degree of freedom we got is 1, and the degree what significance level we have set is 0.001. So what is the value we are getting here is 10.828. Okay. So this table you don't want to worry. If it is asked to solve, and this table will also be provided. So you should know how to take the value. So don't forget, you have to take it like this. You have to find either the question the significance level will be given, or else you have to consider one particular significance level and then you have to choose it. So here the significance level is this 0.001 is the significance level, and the degree of freedom we got by row minus 1 into column minus 1. This formula we got is 2 minus 1 into 2 minus 1, we got the value as 1. So that is why we choose this 1, and across the 0.01 we'll get this value. So this is our value which is absurd, and the value which we calculated is this 507.93. So now we can say that the calculated value is greater than the chi square, the that is chi square value which we calculated is greater than the value which we got from the distribution table. So then we can say that we can reject the null hypothesis, and we can say there is a correlation between male reading fiction and female reading fictions. Okay. And similarly, this is another example of same thing, solving the chi-square. I'll be sharing the PPT shortly, then I think you can go through it, same thing. So here we want to find if there is any correlation between if the students passing is related to the students who live near the university. So here it says the students who live near the universities absurd pass value is 140, and the students who live near the university not passing is 190. So we have to check whether if there is any correlation between students living near the university and the pass percentage, is there is any relation between this or not. So then we have to find the chi-square value, and we have to find the we want to calculate the chi-square value, and we have to check it against the chi-square distribution table, and we have to say whether there is a correlation between this or not. So this is how by using this chi-square method we can able to conclude that there is any correlation between this categorical data or not. So, okay. The next thing is, then we saw in the previous example, for categorical data, we can use chi-square method to find the correlation. And for the numerical attribute, we have to find the correlation coefficient and the covariance. So, by finding this both, we can say whether there is a relationship between the numerical attribute or not. So, let us go to that. So, we know what is this covariance means? We want to find the direction of relationship. It is positively correlated or negatively correlated. So that is denoted with the help of covariance. Okay, so covariance signifies the direction of linear relationship between the two variables. And what is correlation? It says whether two variables are strongly related or loosely related, right? So that will be denoted by correlation. So covariance is also saying the relation, and it will denote the direction, which means it is positively correlated or negatively correlated. When one value increase, is the other value is also increasing, means then we will be getting a positive correlation. When one value increase, another value decrease, then there will be a negative, another way of direction of correlation, right? Negative correlation. So that is said about by covariance, and the correlation will say whether these two variables are strongly related or not. So covariance value will be always ranging from minus infinity to plus infinity. Correlation will be ranging from -1 to +1. So say for example, if I want to give an example for covariance, how will I say? For example, if I have a data, if you consider I have a data, two datas are there. You consider there is a temperature and also ice cream sales are there. Okay. So when the temperature increases, for example, if the temperature is 90, or I can say today is 20 and then 30, 40, as the temperature increase, if the ice cream sale is also increasing, say for example here it is 20, then it is 50, and it is 100. So as the temperature increase, if the ice cream sales rate also increase, and we can find there is a the direction which it goes is like this. So it is said to be as positive correlation. Okay, positive correlation. And another one example also we can say with the same case. For example, I have a temperature as well as I have a coffee sales. So here I can say as the temperature increases, okay, as the temperature increases, what about the coffee sales rate? When the temperature is less, I can say the coffee sales rate is more. As the temperature decreases, the coffee sales rate may be uh, less. So as the temperature increases, no, as the temperature increases, the coffee sales rate will be decreases. Okay, so it will be like, it will be in the other way. So as the temperature I am increasing, the sales rate of the coffee will be decreasing. So this is said to be as a negative correlation. So this is what the relationship between these two variables. So the direction of this relation is said to be covariance, and how strongly it is related said to be as correlation. Okay. So this is what an example for this. So variance means it says about single variable variance, and covariance means that already. I hope two variables vary together. So says in the covariance the relationship, and it is positively or inversely related to each other. And to find the covariance between these two variables, x and y is defined as this. So if you want to find if there is any covariance, the relationship between two variables of x and y, so it is like the particular attribute minus x bar. Okay, it is x bar. X bar means the mean of this, all the values of this particular attribute, and y minus y bar. I hope you know that y bar specifies the mean of the values in this particular attribute, the divided by n. So this, using this formula we can find the covariance between these two variables. And here is another one. We have a formula: population covariance and sample covariance. What is this population covariance? Is the total data set which we have. And what is sample covariance? We'll be taking the subset of the population covariance, and then we'll be finding the relationship. And then we will be relating the sample covariance with the population variable, whether the subset of sample data is related to the population covariance which we found for this. If though this both is related, or it is closer, the values are closer to the population covariance of means, then I can say this sample covariance is related to the population covariance. So population covariance means the total data set. Sample means the subset of it. We will be taking a subset of this population covariance, some sample out of it. For example, if I have a bigger value of temperature and the ice cream value, I will take a subset of this, and then I'll try to find the relation between that, and then I will relate it with the population covariance. So then I will find whether again this subset is related to the population covariance. So only difference in this both is same formula only. Here we will be applying, instead of n in the sample covariance, it is already proved by mathematically. They have denoted the formula given as n minus 1. Okay. So it is like Basel's relation, something like that. Using that, they have proved that for sample covariance, the n value will be n minus 1 here. And now this is an, I hope you this may be clear for you. So here we want to find if there is any relationship between temperature and the this is ice cream sales, right? It's given here at only coffee sales. It is ice cream sales. I want to find whether there is a covariance or relationship between this two variables. So what is the formula? According to the formula, I have to find. So the formula is x minus x bar into y minus y bar full, and then we have to find the summation divided by n. So first we have to find the mean, because we want the x bar, right? X bar means the sum of all, and mean means average. So sum of all this is 265, and divided by the total number of, we'll get 29.44. That is the x bar, and y bar is also found as 25.778. The total value of y divided by the n, 1 2 3 4 5 6 7 8 9, so 9. So 232 divided by 9, you will get 225.778. So for every individual value of I have to find how it is related to the mean, how it is varying from the mean value. So it is we have found it like this values. And here again I have to say whether how this yi value vary from the mean values. Again that we get it from here. So by checking the difference, then we have to multiply. After multiplying according to this formula, we have to sum up all this and then divided by n. So here we are multiplying this both, and then when we sum, we got 1064.89. And after summing, we have to divide it by n. So divide this number divided by, if the n value is 9 divided by n, I'll get 118.321. So what is the conclusion you can say? I hope you know this covariance earlier. So what you conclude from this value? So if you get a positive value, then I can say it is positive covariance. Okay, so I'm getting a positive value. So I can conclude. So this is what the covariance I'll be computing. 1064 divided by n9 value, I'll get 118.321. So that is positive covariance. So I can say there is a positive relationship between temperature and the ice cream. So I hope you know this. And the next thing is the next way of finding the correlation using Pearson's correlation. This problem is also very important. No? You just note it out. Chi-square is important. Pearson's correlation is also a problem is also important in this unit. And so here correlation as usual, it will show whether two variables are strongly related or not. So the Pearson's correlations is denoted by using the formula R is equal to, first we have to find the covariance of x comma y. So already we know how to find the covariance of x comma y, divided by, then we have to find the standard sigma x and sigma y denote the standard deviation of x and the standard deviation of y. So already you know what is standard deviation, how well it is spreaded. So that finding the correlation, and then we have to divide it by how well it's spreaded, you will get the Pearson's correlation. This is expanded, this equation is expanded like this. So already you may be knowing the covariance formula. So this is what the formula is. And then that we have to divide it by the square root of it, of x. Standard deviation we have to find, and you have to find the square root of it. So that will be the Pearson's. So already I have told about what is positive correlation and what is negative correlation. So if the Pearson's correlation value which you get is -1, then you can say it is negative correlated. And whenever you get a value of 1, then we can say it is positively correlated. And if you get a value of 0, then we can say there is no correlation. So this is how we can conclude with this Pearson's value. So let us take an example and work for it. So here we want to find the correlation between the temperature and the number of customers. Okay, customer may be using for any one application. So here first is according to the formula, we have to find the covariance. So already we know if you want to find the covariance, first you have to find the mean value of it. Sum of all this divided by the n value, that is 6, and this is what we did here. And similarly for y, we have to find the mean, sum of average. So here it is done. After finding, then we have to find x minus x bar, y minus y bar. So that is found here. So 97 minus x bar value is 87.33, and we found it. So for every value we found it, then multiplying it, we got this product. So we will be getting this value xi minus x bar into yi minus y bar. After finding this multiplication, we know that we have to sum up all this according to the covariance formula divided by n. So when you divide it by n, here we have taken the sample. So it is 6 minus 1 divided by, that is 5, we'll getting 22.46. So this is the covariance value. Okay, and then after finding the covariance between these two variables, now we have to find the standard deviation So we know what is standard deviation, right? Here, if you see the standard, for example, if you want to know about standard deviation, here I have noted standard deviation means how well your data is spread. So if you see here 4, 5, 6, 4, 6, the data here it is spreaded only between 4 and 6. But if you see here in this data 1, 2, 6, 9, 3, the data is spreaded across 1 to 9. So the standard deviation for this particular data is large. So that is what we are going to find here. So first we have to find similarly x minus x bar. So we have the x value, mean value already we found, and when we find x minus x bar the whole square, you will be getting the value. So if you remember here, we found the x bar value already there. So we are getting the, and x minus x bar value also we found. So we want to find the square of it, we'll get all these things. And then we have to find the sum of all this value divided by the total n value, that is 5, that is n minus 1. That is what we have considered here. So when we divide, you will get 8.13, and here for the standard deviation of y, we get 3.1. So now if you apply to this covariance formula, first we have to find the covariance of x comma y, and then we have to find the covariance of, we have to find the standard deviation of x and y separately. So that we already found it. So when you divided covariance of these two variables, 22.46 divided by the product of these two values, you will get this, that the value is 0.8. So already we know from this conclusion, whenever the value is 1, you can say it is positively correlated. So the value which we obtained here is 0.8, which is close to 1. So then we can say these two variables are positively correlated. So if it is close to minus 1, we can say it is negatively correlated. Since we got a value zero point 0.8, we can say it is positively correlated. Okay, ma? So I hope you got it. Do you understand until this? So how many of you got it? The problems? Do you understand the problems, ma?